Hello dear students, welcome back to a new video. Today I'm gonna explain for you the natural base e, also the natural logarithm. So first let's understand what's e. E is irrational constant or is irrational number and the value is about 2.71828 and is also claiming as a irrational number, same as pi when we had using pi for a circle 3.14 starting and it goes more. Okay students, we have some important notes about e or exponential let's say power or natural exponential. The domain going to be a real number, so when you have e power x you can substitute any value for x because we know that domain is going to be all numbers that is allowed to substitute in a value of x. A range is going to be y greater than 0. This range, it may change, is not always y greater than 0. In case if you have e power x, then it's y greater than, but if you have a plus or minus a number مثلا k, then the range can be changed. Same as the y-intercept also. I will show you by example. Okay, this is the graph of e power x, the natural exponential. Why we call it natural exponential? Because the base b, if you remember, we had learned y equals b power x when b is not 0 and b greater than 1. This is calling exponential function. Why exponential function? Because we have x or we have a variable in a power. But if you have the base e, then we call this one natural exponential. Alright, so how to graph this one? As you can see, we never get for y, we never get negative. As you can see here, there is for y values there is no negative for e exponential. The graph starting from 0 to infinity about range, and about domain of course is all real number from left to right. This graph continues. Okay students, right now let's see some examples. Dear students, let's understand more about the graph. You have three functions in front of you here: e power x or e exponential minus 4. This is the first function. How to graph this type of graphs, this type of functions? It's very easy students. All you need to do is what? This is a coordinate as example. This is the coordinate. Okay, this is y positive, this is x positive. First of all, graph these functions. First one we have f of x equals e exponential x minus 4. How to graph this one, students? There is a number with the exponential and the number is -4. We call this one horizontal asymptote or HA. I need to find out -4 first on the y-axis. This is -4, mister. Okay, good. Then after finding -4, you need to draw a broken line, horizontal broken line passing through this number. Okay, and the graph going to be starting from -4, and if you find out let's say y-intercept equals how much y-intercept here? Y-intercept means x equal to 0. So when x 0, we will get e power 0 minus 4. The answer is -3. E power 0 equal 1 minus 4 equal -3. So the graph crossing the y-axis in -3. So the graph going to be something like this, and extending, it goes to infinite. So if you calculate the domain here going to be all real number, because about x from negative infinite to positive infinite, this graph continues. There is no problem. About range, range mean y value, where the graph vertically started. If you check the graph vertically, it started from -4, but -4 not included because it's a dashed line. Till this graph continues to infinity, so till positive infinite. Okay, students, second one, you will do the same. We will draw the coordinate plane. But the problem here is what? There is a negative in front of the exponential. So, but this number is plus 0, right? So our horizontal asymptote is on 0. So we will draw line on 0. Dear students, if you make table for this function, this is x, this is y. If you substitute values, any value, like if you substitute for the values of x, مثلا 0, 1, 2, -1, -2, you always get, if you substitute 0, you will get e power 0. E power 0 equals to 1, right? But there's a negative, so going to be -1. So you will get -1. If you substitute 1, we know that e equal to 0.7, so you will get -2.7, and so on. So you always get negative values. When you substitute, when you, let's say, plot them, passing through 0, -1, we found, so the graph going to be something like this. So if you calculate the domain going to be all real number. And how about range? Pause the video if you want to know the range. Check it, solve it by yourself, then come back. So the range, we know that is vertical. Horizontally is all real number. Doesn't have any problem, this graph. But vertically, this graph starting from negative infinite till where? Till 0. The horizontal asymptote is on 0. So from negative infinite till 0. And 0 also not in the range. And finally, students, we have another one. First of all, we need to find out this value, which is horizontal asymptote 4. So on 4, I will draw a line. Suppose this is 4. Okay. And there's a negative in front of the exponential. So again, the graph's going to be similar as question 2. So the graph goes down. If you find out y-intercept, so you will get 3, right? Because it's going to be 4 minus e power 0, so equal to 3. So 3, where is 3? This is 3. The graph going to crossing 3 on the y-axis and goes down because it's negative, same as example. So domain here, again, all real number, because we have no problem about x values. We can substitute every values for this one. But for range, it's starting from negative infinite till 4, and 4 not in the domain. So from negative infinite until 4. Dear students, about natural logarithm, we know that logarithm is written like that, log base b of x, correct? But when b is not 0 and b greater than 1, this is calling normal logarithm. This is okay. But if you change this b to e, like this, log base e of x, what will happen? In this case, this is calling natural logarithm. And also, instead of log, we can say this one log base. When the base is e, we can say ln x. So when base log have a base e, will convert to ln x. This is exactly same as log but with the base e. So the combination or the relation between len and log, they apply everything the same, but the only difference is what log is more common, is more general, but len or ln, calling natural logarithm, have only the base e. And by the way, all properties that we have for log is applying for len, like ln of xy. Since there's multiplication, I can say ln of the first one plus ln of the second one. Also, second property of quotient, when I have log ln x over y, I can say equals to ln of x minus ln of y. And the property of the power also, when you have ln x power k equals to k ln of x. And the fourth one, which is ln of e equals to 1, or e power ln of x is only equal to x. Same this calling inverse. If you remember, when we had log base b of b equals to 1, and here ln mean log e of e. This is the meaning. ln mean log e, base e. So of e, both of them are the same, so the answer equals to 1, right? And also, if you remember, here we had b power log base b of x equals to 1, right? So this is same thing. ln can cancel, equals to 1. 1. Okay, dear students, about graphing ln x is same as logarithm, that this value of x not accepting negative numbers, only positive numbers, like the number more than 1. So we can say x must be greater than 0 in this case. X must be greater than 0, then you can input. And the graph going to be same as log. We have a vertical asymptote on 0. We cannot substitute 0. And the values that we get, the graph going to be something like this. Okay. So domain here is starting from 0. domain يعني horizontally, starting from 0 but not 0 till infinite. And how about range? Range from down to up is all real number. It's going to be all real number. Exactly the domain and range of this function is opposite to exponential, because ln of x is inverse of e exponential x. Same exponential and logarithm. Okay, students, in the end of this video, I want to explain or simplify some of the exercises related to ln and e as solving. So let's solve, or let's simplify each of these expression. First one, I have ln e power 1. As I told you, ln of e, this is they cancel each other, so we will get only 1. ln e, again they can cancel, and you have a power. You can move the power back, or directly you can cancel. You can say x minus y times by ln of e, and ln they cancel each other, so we will get only x minus y. For this one also, e power ln, so we have ln and e, they can cancel each other. This is calling inverse property. When you have a log base b of x, this cancel equal to x, right? This is property. So this is the same, so equal only to x. But in case if you have a number in front of ln, you need to move the number back, make it e power ln x power 3, then you can cancel ln with e, which is equal to x power 3. Be careful in this case. Dear students, one more thing that some students they confuse or they don't know how to solve. They don't know the difference between if you have 3 ln e power x and e power 3 ln x. In this case, in this one, in the first one, I have this power of e, right? I can move this power to the next of 3. I will get 3x ln e. But this one, I can move the 3 power back. I will get e power ln x power 3. So ln and e cancel each other, we will get 3x. And ln and e cancel each other, we get x power 3. So these are different. Please be careful. I hope you enjoyed, and until next time, peace out. Bye bye.